All right, this is section 6.2, part 3. We're trying to get a couple points for this function right here. And I've been using negative x values, which they came out to be very small, which makes sense because we have an increasing function, and we also have a horizontal asymptote at y equals 0. So it should be getting closer and closer and closer to y equals 0 right here. So we should be getting very small numbers. So I'm going to switch and use positive x values over here. So we'll look at 2 and we'll look at 3. Okay, so 1/2 times 4 raised to, we'll do 1 and 3. We'll do those. Or sorry, 1 and 2. Raised to 1, so it'll be half of 4. So that would be 2. And then 1/2, 4 raised to 2. So half of 16, that will be 8. Okay, so we'll have 1, 2, and 2, 8. Okay, so it looks like it'll be going up. Try that again. Going up like this right here. Okay, and let's go ahead and state the domain, which we already know. That's negative infinity to positive infinity. That doesn't change in this section. Range goes from 0 to positive infinity. And we already labeled our horizontal asymptote. We said that is y is equal to 0. This is what it should look like. Now notice we have our points 0 and 1/2 right here. 1, 2, and 2, 8. And it's also increasing, and we have a horizontal asymptote at y equals 0. Now let's talk about reflections of the parent function f of x is equal to b raised to x. So if we have a negative in front of b, what that's going to do is it's going to reflect f of x equals b raised to x about the x-axis. So it'll have a y-intercept of 0, 1, and it'll have a range of negative infinity to 0. It'll also have a horizontal asymptote at y equals 0. The domain does not change. Now, if you have a negative in front of the x value, then it's going to flip the parent function about the y-axis. So if it's in front of the entire function, in front of b, it's going to flip about the x-axis. If you have a negative in front of the x, it's going to flip it about the y-axis. So here what you have is a y-intercept of 0, 1. You have a horizontal asymptote at y equals 0. The range goes from 0 to infinity, and the domain does not change here. Okay. Now let's think about, let me get rid of all my markings. Let's think about this right here, the y-intercepts. Okay, so for this function, the parent function, we had 0, 1. But now that we have a negative in front of b, which that's going to affect your y values. It's like multiplying times negative 1. Well, 1 times a negative 1, so what you're essentially doing is taking this times a negative 1, and hey, that's going to give you 0, negative 1, which is what we see here. Now, looking down here, when you have the negative in front of x, well, that's going to affect your x values. But since the parent function is 0, 1, it's like multiplying a negative 1 times a 0. So negative 1 times 0, which essentially makes it still 0, 1, which is what we're seeing right here. Okay, so here's our original function right here. And that keeps on going. That's 2 raised to x. Now, if I have a negative in front of that, so negative 2 raised to x, it is flipping over the x-axis. Okay, so now we're going down this direction. And notice how we have gone for our range. Now it's going, let's see, negative infinity to 0. Yeah, so it's going negative infinity. It's going down here, but it's getting closer and closer to 0 up here because that's our horizontal asymptote. So it starts here at 0 and goes down. So that's our range. Now again, it never gets to 0. That's why you have a comma, or not comma, but a parentheses around the 0, because it never actually gets to 0. Okay, so here's our function right here. Let me change that. Okay, so that is 2 raised to x. Now if we have a negative in front of the x, we'll notice how it flipped it across the y function like that. Okay, so now we have flipped across the y function. And notice the range here, it goes from positive infinity to y equals 0. So actually it goes from 0 to positive infinity. You always list the lower or the smallest number first and then the larger number second. Okay? And also, let's look at, let me change the color of this. We'll use blue. Okay, notice how in the original function 2 raised to x, all your y values were positive. Okay, so up here we had a positive 2, 3, 4, 5, 6, 7, 8. Keep going, keep going, keep going. But with the blue function, so negative 2 raised to x, hey, now they're all negative. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, so that negative affects the y values. Now let's come over here. Let me draw this blue value. Okay, so in the 2 raised to x, notice how you have, over here you had negative 2, negative 3, negative 4, negative 5. But when you flip it over, hey, they become positive 4, positive 5, positive 6, and you keep on going. Notice how over here, 1, 2, 3 for these points, this point, and this point, when you flip it over for this point, this point, this point, well, now they're negative 1, negative 2, and negative 3, so your x values have been affected here. Okay, so let's look at this right here. We've got, we need to determine the equation of the transformation of the function f of x equals 5 raised to x, and we'll graph this below. No, sorry, it's graph below. So we need to take this graph right here and try to figure out the equation for that graph. Now let's first graph the function f of x equals 5 raised to x, and we'll use blue color for this one. Well, we will use it for the graph. Okay, so we're going to have a t-table, and we'll use, let's use negative 1, 0, 1, and we'll use 2 as well. Okay, so 5 raised to negative 1, that's 1/5. 5 raised to 0 is 1. 5 raised to 1 is 5. And 5 raised to 2 is 25. That goes off the chart, so we won't use 2. So let's plot those. And notice for this function right here, in number 1, b is 5, so it's increasing. And we have a horizontal asymptote at y equals 0 because we did not shift up or down. Okay, so we have a horizontal asymptote at y equals 0. We'll plot these points, negative 1, 1/5, so that's going to be really close to this right here. 0, 1, hey, that overlaps with this one. And then 1, 5. Okay, so it looks like it should be doing, and then we had 1 at 25 as well, so that's really high up. So let's just combine these right here, and we know that's getting really, really, really close to y equals 0. Whoops. Something like this, okay? Now notice, when my x values, say this one right here, we'll label this one at negative 1, 1/5. And we'll label this one, that is 1, 5. If we look at the graph that they gave us, right here we have 1, and it's really small. I'm going to assume it's 1/5. But this one over here, right here, this one's negative 1, 5. Okay, notice that what's happening is our y values aren't changing, but our x values are changing. So it's also flipped across the y-axis. Okay, so when it flips across the y-axis, so it looks like this one right here, looks like we should have a negative in front of the x. Okay, so our function for this graph that they gave us is 5 raised to negative x, and that's it. Now let's look at this one right here. So again, we already have some numbers for the function x raised to 5. We had negative 1 1/5, so that's about right here. And then we had the 0 1 right here, and we had 1 5. That goes off the chart. It's about here. Okay, and we had the y equals 0 asymptote again. Okay, now notice here, and let me label the points again. Negative 1 1/5, and this one is what is that? 1 5, and this is 0 1. Okay, notice here we have negative 1 negative 1/5. Here we have 0 negative 1, and then at 5 we have 1 negative 5. So notice what's changing here is our y values. Okay, so since our y values are changing, and that looks like this function right here, that means that we have a reflection about the x-axis, and we need to put a negative in front of the entire equation. So f of x is equal to negative 5 raised to x. That is our function. Now let's look at this one right here. Okay, so let's go ahead and get a few points for 1 over 5 raised to x. So I need a t-table. So we'll do negative 1, 0, and 1 again. Okay, so 1/5 raised to negative 1, that's 5 raised to 1, or 5. Anything raised to 0 is going to be 1. 1/5 raised to 1 is, 1/5. So let me plot those. So we got negative 1, 5, so that's here. We got 0, 1, that's here. And we got 1/5, that's here. Actually, sorry, that shouldn't be down there. That should be up here. And it goes off the chart just a little bit for the negative 1. We'll put it about right here. Okay, so it looks like this will be our function right here. Okay. All right, so it's a decreasing function, and looks like what happened is, let's just label the points. This is 0 1. We'll say up here this is negative 1 5, and right here that's 1 1/5. Okay, for this one right here, that's 1 negative 1/5. Right here, that is 0 negative 1. And then right here, that is negative 1 negative 5. So what has changed is all of our y values. Okay, and looks like we have flipped over the x-axis, which means what we need to do is put a negative right in front of the entire function. Okay, going back, it looks like, not this one, but this one right here. So we flipped over the x-axis, which means we need a negative in front of that entire function. Now let's look at this one right here. Okay, we'll go ahead and graph what we know about 1/5 raised to x. We've got negative 1 5. So that'd be about here. And then we've got 0 1. Hey, that overlaps. And then we've got 1 5. Okay, so it's going, whoops, can't cross over that. It's going about here. Okay, so notice we've got these points right here. Notice what's changing is the value for your x values, and it's also flipped across the y-axis. So the x values have changed, so what that means is we need to have a negative in front of the x, and that is our function right there.